Okay. On that previous question, I saw the little code -T. Sorry, I did not see that little code -T. However, they didn't let us have a link to open up the table. Here I do see the -T. Believe they are looking for us to specifically use the TI-84. A certain flight arrives on time 88% of the time. Either it's on time or it's not. We have a fixed number of trials, 156. So N is 156, 88%, turn that into a decimal, we've got 0.88. And they were randomly selected. That's probably going to give us independence. There's only on time or not on time. And we're keeping that with 0.88 from trial to trial. So let's first check whether or not the conditions hold that we can use the normal approximation. N times P, 156 times 0.88. I'm getting 137.28 for the mean. So to come up with a variance on the left-hand side here, I still have to multiply that by 1 minus P, which is 0.12. So I'm getting a variance of 16.4736, and that is greater than or equal to 10. So my standard deviation is going to be the square roots of that 16.4736. And let's see. Back here, we were finding that, yes, it's okay to use the normal approximation. So let's see what parts they were asking for. All right, so we're asked for the probability that exactly 125 flights are on time. And we need to use the continuity correction, going half a unit left to 124.5 and half a unit right to 125.5. So let's see here. 124.5. Wasn't expecting that. Sorry, hold on a minute. Lower limit, 124.5. Okay, so again, we were doing the continuity correction there. Now going half a unit to the right, 125.5. It's going to let me type it in or not. Here we go. I don't want to take the number that's given there because I'm doing the graphing here. Thought it was going to show us some shading, but it must be such a tiny portion. So let's go over to normal CDF. From 124.5 to 125.5 with that mean of 137.28 and the standard deviation of 16.4736. To 4 places, that's going to round to 0.0010. To go with at least 125. And by the way, if you're using the old school approach, after doing the continuity correction, half a unit left or half a unit right, you would then have to calculate z-scores. using quantity x minus mu all over sigma. And then you would look at, for the z-score going with 125.5, look up that z-score that goes with it. The table is going to give you the area to the left. Then look up the z-score going with the 124.5. The z-score going with 124.5, the table will give you back to the left what area you have. Since you're just looking for what is in between, you would have to subtract what you have on the rightmost minus the smaller area that you have from the leftmost, so that you're taking away the extra unshaded part. Okay, so greater than 125. Now, again, I don't want to go with the number that I'm going to get from the picture. Let's see if it'll draw it this time. I'm going to start at 124.5 and shade to the right of that. The window is only going to show to 154. So I may not get exactly the number I would get from normal CDF. Let's see what happens. 124.5 with the continuity correction up to 154. Now we're getting our drawing. That's quite a bit shaded. And we're getting a pretty big number there. Let's see what happens when we use normal CDF this time. So again, with the continuity correction, half a unit left. It can't go to infinity, so we put in the largest positive number that we can. U is 137.28, and sigma was square roots of 16.4736. Again, a pretty large number. Looks like this is going to round to 0.9992. Okay, that one's good. Fewer than 146. We're going to have a little problem with the continuity correction there. That's saying X is strictly less than 146. And that would mean then that it is less than or equal to 145. Because we're shading to the left now, our continuity correction, we're going to be going half a unit to the right and shade back to the left of 145.5. I want you to also know that the continuity correction is only for when you are approximating binomial probabilities. When this holds true and you're approximating binomial probabilities. If you have something that's already normally distributed, you don't do the continuity correction. All right, so let's see here. Bum, bum, bum. Let's get a pretty picture of this, where we're going to shade from 121 to 145.5. And it did not clear out the previous drawing, so give me a moment to do that. At least I don't think it did. Let's try it again. Our window, we're going, the far left is 121. All right. So lower limit of 121, an upper limit after the continuity correction, and applying that fewer than 146 is the same as saying less than or equal to 145. Quite a bit shaded there, something pretty large, not as large as the last one. Let's be extra sure though by going to normal CDF, because I may have cut off too much on the left with that window. Now we go with the negative number with the largest absolute value, going towards negative infinity, up to 145.5, same mean and standard deviation we just dealt with. And that looks pretty similar to what we saw by the picture. So 0.9786 it will round up to. And finally, part D, the probability that we would be between 146 and 150. That's actually going to be similar to part A, but we go to the left of the 146 by half a unit with a continuity correction, and half a unit to the right of the 150. So let me clear out the previous drawing. Half a unit left of 146. Our lower limit is going to be 145.5, and our upper limit will be 150.5, half a unit right of the right-hand endpoint. And we just get that little sliver. Going to be around 0.02 something. So, normal CDF. We're going with that continuity correction. Same mu and sigma as in the previous parts. That's going to round up to 0.0209. And it's good.